Show that the polynomial p of x equals x cubed plus 4x minus 12 has exactly one root. So a root is where the graph crosses the x-axis. And a cubic polynomial, so that's where the polynomial is equal to 0. And since the degree of the polynomial is 3, there can be up to 3 roots. But this particular one evidently only has one root. Let's see why. Well, first, let's show that it has a root. And we'll use the intermediate value theorem to show that it has a root. Let's calculate p of 0. That's easy enough. P of 0 is the constant term, negative 12. And now let's see if we can find an x value where the output will be positive, because this output was negative. And if the polynomial crosses from having a negative value to a positive value, then it must have a root in between by the intermediate value theorem. Of course, this is because our polynomial is continuous, and so the intermediate value theorem can be applied. So p of, let's say, it looks like even 2 will work. P of 2 is 8. 2 cubed is 8, plus 8, that's 16, minus 12, which is 4. So p of 0 is negative, p of 2 is positive, so somewhere between 0 and 2, our polynomial has a root. P of 0 was negative 12, p of 2, so this point is on the curve, p of 2 was equal to 4. So this point is on the curve, connecting them with a smooth curve. We see that there's a root. So by the IVT, p of x has a root somewhere between x equals 0 and x equals 2. So we'll say that it has a root in the open interval from 0 to 2. So we'll say in the interval. Somewhere in that interval there is a root. Now we want to show that there is exactly one root. So we know it has a root. That means it has at least one. So now we want to show that it does not have more than one. To show that it has exactly 2 roots, what we'll do is we'll assume that it has 2 roots. So assume or suppose, well, suppose is more like it. Suppose that p of x1 is equal to 0 and p of x2 is equal to 0. So assume that the function has 2 roots. Now the function having 2 roots means that at the endpoints, I'm going to consider the interval, the closed interval from x1 to x2. Then at the endpoints, the polynomial has the same height, namely 0. So we should consider using Rolle's theorem. Rolle's theorem says that if the function is continuous on the closed interval and differentiable on the corresponding open interval from x1 to x2, then the derivative has to be 0 somewhere in between. That's Rolle's theorem. And our polynomial is continuous. So p of x is continuous. It's a polynomial. It's continuous on minus infinity to infinity. So in particular, it's continuous on the closed interval from x1 to x2. And the derivative of a polynomial is another polynomial, which is defined everywhere. So p of x is differentiable, and you can find the derivative for any x. It's differentiable for any x, in particular, on the open interval from x1 to x2. And again, since p of x1 is equal to p of x2, they're both 0, all three of those conditions together allow us to use Rolle's theorem to conclude, by Rolle's theorem, there exists a number C, there is a number C in the interval from x1 to x2 such that P prime of C is equal to 0. This is what Rolle's theorem tells us. So again, if there are two roots, x1 and x2, so that P of x1 is equal to P of x2, then somewhere in between there is a critical number C where P prime of C is equal to 0. But let's check P prime. What is P prime? P prime of x is 3x squared plus 4. If we try to set this equal to 0, we see that there are no solutions. 3x squared is at least 0, plus 4 is at least 4. If we try to go through the motions, we would see that 3x squared is equal to negative 4, and that x squared would have to equal negative 4/3. X squared can't be negative. No solutions. So if we were to suppose that our polynomial had two roots, then we would get the contradiction that x squared would be a negative number. And therefore this supposition must be false, and so the polynomial cannot have two roots. So since the supposition, the supposing that the polynomial had two roots, I'll call that the supposition, is false. Well, let me just say, since the supposition leads to the false conclusion that x squared can equal negative 4/3, that's definitely false. And assuming this statement here, assuming that we have two roots, leads us to this false conclusion, then this supposition must be false. So since the supposition itself leads to a false conclusion, it must have been false. And therefore we cannot have two roots. So P of x cannot have two roots. And if it can't have two roots, then it has either 0 or 1 roots. And we already showed by the intermediate value theorem that it had a root. So it has exactly one root, putting those two together. So the IVT, to recap, the IVT implied that there was at least one root. And then Rolle's theorem was used to show that there are not two roots. So if there's at least one but not two, then putting those together, there is exactly one root. And that's what we wanted to conclude.